We'll start exactly in 2 minutes, guys. Just give me 2 minutes. In the meanwhile, if you have any questions, just post it in the live chat itself so that I will get back to you. Okay, so the streaming has started, right? Everybody is able to hear my voice because I don't have any guests today, so I'm pretty much finding it difficult to understand if I'm audible or not. Can everybody type in if I'm audible or not? Just type in yes, yes, or something like that. I think there will be some delay on YouTube chat or something like that. Okay, yes, I can see yes. Okay, let's just wait finally for 1 or 2 more minutes and then we'll quickly start. I have a lot to cover in today's session. We will cover the use case, what exactly the use case is, what is EDA, and what are the different techniques we use in EDA, and a lot of things are there in this particular session. And it's going to be very, very good, and it's going to be really informational for you. That's what I feel. But always there would be a room of improvement. But let's see. We'll try to achieve as much as possible in the next 2 hours. People are joining in. How much so far? 21 people watching. Not bad. In case you want to share the video to your friends and colleagues, do that immediately, and I will quickly start in 2 minutes. Not 2 minutes, just 1 minute. Okay. Okay, let's get started, guys. I think my introduction is not required. I think many of you might be knowing me. But yes, hello everyone. This is Satyajit Pattnaik and welcome back to my channel. In case you are new to this channel, please subscribe the channel and hit the bell icon to get notified on my future videos and sessions. As most of you already know, I have recently started doing such live workshops and webinars. So today's topic is going to be on exploratory data analysis. So we'll try to understand what exactly use case we are doing, what is EDA, what are the different techniques used in EDA, what are categorical analysis, numerical analysis, and a lot of topics will be covered. So let's get quickly started on this. In case you have any questions in the middle of the session, I already have another tab in front of me, so I'm looking at the chat box as well. You can post it as a comment or in the live chat, and I will try to get back to you with the answers. In case your questions are not answered or somehow missed, you can definitely reach out to me directly on LinkedIn. Link to my LinkedIn profile, I think, is already shared in the description below. So just a disclaimer, some I have some good presentations for today's session. I have this use case presentation. I have some data encoding presentations. A few of them, a lot of presentations has been created for today's session, and of course, we will also check the coding part, how the EDA is done on a particular code, particular use case. Okay, so in case you need these presentations and codes, which I'll be showing you in this session, all of them are accessible to you once I get 100 likes on this video. That's not kind of demanding, but just a request to like, share, and subscribe the channel. And trust me, we'll come up with a lot of such free webinars on various other topics related to this niche. So let's get started. Today's topic is as I already told, it's going to be on EDA, but I have chosen one use case which I have already talked about this use case in my channel couple of months back. So it could be repetitive, but trust me, telecom retention or churn prediction or these kind of use cases are very common use cases. They are not very relevant to, like, they are not just relevant to telecom domain. The same use case is applicable throughout the industries, throughout every domain, be it on the banking domain, be it on the gaming domain. In case of any domains, this retention use case is very much applicable. Okay, so I will be talking with respect to telecom, but in case you want to try to visualize in your mind how it works in the banking domain and other domains, I can also give you some examples. Okay, now telecom retention is a pretty classic example because I come from a telecom background, so I usually use this use case. Now retention, what is retention? Retention means For a company getting a new customer, now why I am talking this, because as for EDA, the understanding of the use case plays the vital role. Because if you don't understand the use case, if you don't understand the domain knowledge, if you don't have that, then probably if you are doing ETA, that's not going to be value add for your use case. Okay, so you always have to understand the domain, and then you go ahead and do some analysis. Okay, that's the basic thing. And today's topic is going to be very relevant for the data analysts who are working out there, or who are data analyst enthusiasts. It will be very much informational for them, and of course for data science people as well. Okay, now let me explain you what retention is. Try to understand everything in details, and then we will proceed slides one by one. Okay, now let's say I am currently using Vodafone. Now, probably because of multiple reasons, I might switch to Airtel or Jio, or it could be any telecom provider. Now, people churn because of multiple reasons. Okay, the reason could be a service impact. Let's say I am not having good service from the last couple of days or from last couple of months. So I'm already pissed off and I have already thought about leaving the company, and definitely I will leave the company. Leave the company as in I leave the provider. It could be because of monetary reasons as well. Let's say in Vodafone I'm paying 999 rupees. Airtel is giving me the same features in probably 499. Okay, so people will churn. Now just try to visualize this when it comes to gaming domain. Now if you ask me how retention is useful for gaming domain, let's say today you are playing one game, and tomorrow probably in 1 week you leave the game. Like if you are not interested, you uninstall the game and you install a new game. There could be multiple reasons for that. One of the reasons could be the level. Let's say you are in 110 level, so the 111th level is very difficult for you and you are not able to cross it. You are trying from the last couple of days, from last 2 3 days, you're not able to cross it, and you are a pissed off player right now, and you churn and you leave. Okay, I'm not going to go ahead because I'm not able to cross the level, or else the levels are too easy for you. In those cases also people churn, people leave, that this game is so easy, I'm not going to invest my time here. Okay, in banking domain, company like people churn. Today you are using ICICI, tomorrow probably you go to HDFC, and day after tomorrow probably you go to Kotak, because Kotak is giving you more FD rates or more RD rates. Could be of multiple reasons, right? Now our task as an analyst is, or as a data scientist is, to analyze the customer's data and to understand what is the reason of churning. And if we understand that, then probably we can use some techniques, or use some sales, we can talk to the sales team and give them some offers and try to retain them. Because for a company, retaining a customer is less expensive as getting a new customer. Okay, so I think you understood. Overall, this is going to be the agenda for today's session. We'll try to understand the overview of the churn in telecom scenario, why data science is used, and probably data science approach to build a robust churn strategy. Will not be going through that because today's session is just on the EDA part. So I will try to explain you what are the different churn scenarios and why data science is used, and quickly we will jump into the ADA presentation, and then we will have the hands-on coding. Okay, any questions so far? Network, any issues guys? I don't think there is an issue. Bhargav, yes, recording will be available. This is my videos are always available on YouTube, so you can easily watch it later on as well. Okay, and let's get ahead. Okay, so this is the background of with respect to telecom. Now operators are losing share in today's competitive market. Okay, industry and external outlook, there is a tougher telecom environment right now in India at least. Okay, tougher telecom environment, smarter and more demanding customers. These days, customers have been demanding because they have a lot of options. Earlier days, BSNL or Uninor, there were just limited options, so people were not demanding. It could be of multiple reasons why customers have been demanding these days as well. Internal outlook, there are tremendous growth potential and some of the key questions that clients ask around churn. I'll leave this presentation to you so that you can go through it. Okay, there are different subscriber churn can be in different forms and not just exit from the base. Now, what I told you is one naive example which I talked about 10 minutes back was people churning from Vodafone to Airtel, right? That's just one way of churning. There could be multiple churn scenarios as well. One of the churn scenarios could be a tariff plan churn. For example, you are moving from a 999 plan to 599 plan. Now your question would be why it is considered as churn? Because churning is something where there is a revenue loss for the company. It's not always mandatory that if you leave the company, that is only called as churning. It's not like that. There could be tariff plan churns, there could be service churns, there could be product churns, and there could be usage churns as well. Okay, tariff plan churns, as simple as that. Example, moving from a 50 euro plan to a 30 euro plan monthly. So straight away 20 euros lost to the company per month and per candidate. Service churn. Example, weekly, monthly subscription. Let's say you are on a weekly subscription, you probably churn it, you probably don't use it. Or maybe you are on a monthly subscription, you move it to a weekly subscription. So that is also one kind of churn. Some other kind of churns are product churn, postpaid to prepaid. Now in postpaid, you must be knowing that I have a question, sir. After learning Python programming, what it will affect to the job sector? After learning Python programming, what it will affect to the job sector? Not pretty sure about your question, Yuvraj. You can connect me on LinkedIn. Probably we can discuss. So product churn is postpaid to prepaid. Today you are on postpaid. Maybe after a month you move to prepaid. So there is a significant loss to the company. Okay. Now, why I'm talking about this is ultimately the goal is to identify the type of churns, because there could be 10 people. Let's say your model is going to predict that these are the 10 people who are going to churn. If we understand that out of the 10 people, 3 are falling in the tariff plan churn category, 2 are falling in the service churn category, and 2 are falling in the product churn category, we will probably be, acting upon it. Like we will be having a better actions for them. If we just randomly understand that 10 people are going to be churned, we don't know what categories do they fall in. So we don't know if I'm going to offer them something, are they going to accept it or not, right? So customer churn prediction is one thing, and after that we also need to understand the type of customer churn. Many in Google, in Kaggle, lot of use cases are there related to these areas. People just know that okay, let's build a classification model, it will be able to predict this, that's it. People don't know the end-to-end use case, they don't know the business knowledge about it. So that's why I'm explaining you everything so that you understand. Okay. And there could be a usage churn as well. Let's say probably you are using the data plan, and let's say due to some reasons you have stopped using that because of COVID. Many people are working from home, people have Wi-Fi at home, so your data plan is going to be, it's not going to be utilized. So people go for an inactive or a zero usage as well. In that case, it's a loss to the company, because not many people will do the recharges with respect to the data plans, right? So understanding the type of customers are very important. This is a very high level decision cycle of a subscriber, changes as per needs and or experiences. Now this will explain you everything about the telecom related customer churning. Now I am a mobile customer and I haven't thought about churning because it's too complex, or I don't have time, or it's not worth it. So I'm this kind of customer that I haven't thought about churning because it's too complex for me. I feel lazy going and doing these kind of activities, understanding what Airtel is giving, what Jio is giving, and all those things. I'm quite happy with Vodafone, so I am kind of an inert subscriber. Okay. I'm a mobile customer. I haven't thought about churning because my operator is the best. Now my father falls into this category because he's a BSNL subscriber and he's using BSNL since last couple of years, not couple of years, last 10 years or 20 years. Okay. So he is an unconditionally loyal customer. So irrespective of that, if n number of features also comes in tomorrow, probably Vodafone gives in 199 everything, still he will not be able to churn the BSNL. because he's an unconditionally loyal customer. I'm a mobile customer and I have thought about churning, but I'm logged in by contract. So I'm not pretty sure if it is applicable in India or not, but outside India, lot of companies are having contracts. Okay, when you take a contract of 12 months or 24 months, that is basically cheaper as compared to the monthly plans. So even if you have thought about churning, but you are binded up with a contract, these type of customers are called as logged in subscriber. Okay, they are also safe to the company, they will not leave the company. I have thought about churning and I am not logged in any contract and I have decided to stay. That means this customer is a conditionally loyal, so he has thought about churning, he doesn't have any contract, but luckily he has decided to stay. Let's continue, let's see what happens. So these kind of customers are conditionally loyal. The customers who don't have any contract, they have thought about churning and decided to leave because they have found a better offer. These are conditional churners. Because my needs have changed, these are lifestyle migrators. Now these type of customers are very, these type of customers doesn't really stay with one particular company, they switch. Yeah. So Sagar, yeah, network issue is also one of the reasons. I thought you were telling me that I am having network issues. Okay, because I'm not satisfied. These type of customers are also really hard to retain. Even if you give offers, they will not be retained because they are not satisfied customers. Okay, probably if it the satisfaction level is with respect to monetary aspects, we can give some lower plans and try to retain them. But if the customer is not satisfied with respect to services or some network issues, then it's very difficult to retain them. Okay. It's This webinar is not going to be. I don't have any outlier prediction or treatment related to this, but I do have the theoretical part, but I don't have it in the practicals. I doubt I have it in the practicals. Okay, I think I have it in practicals as well. I'll show you something related to outlier predictions and all those things. So these are the four churn segments, loyalty drivers for each segment: conditionally loyal subscriber, conditional churners, lifestyle migrators, and unsatisfied churners. Okay, so these are some of the slides which is not required for this particular session, but you can just overlook and have a look at it. High level overview of a data science led approach to manage churn. Many people are really not aware about this particular phase. People, especially who are picking out the Kaggle data sets, trying to do some kind of models, create a model which can predict the customers, they are just restricted to these areas, just first part and the second part. Third part, I'm really doubtful. I don't know anybody who knows about it. But people who have actually hands-on experience working on the industry level problems, they will understand what exactly it is. Okay. So first step is going to be capture and analyze. Now capture and analyze means we have to capture the data and then analyze the data. So your EDA basically falls into this category. Okay, acquisition of the data, tariff and usage data, customer level data, recharge data, monthly snapshot. So whatever data is it possible to capture, you first start capturing it. Data collection is a integral part of the data analysis field. Okay, so first of all we have to capture the data, collect the data, and then we have to see which features are important, which are not important, and that's where your ADA comes into picture. So business understanding, identify data requirements and explore data availability, request and extract data required to build a model, aggregate, clean and standardize data in desired format for model. So the first section is going to be the collection of data and EDA. The second section, which is nothing but reporting and predicting. Now, business analysis of standardized data, predictive model designing. So this is where you create your data science models. This is where machine learning comes into picture. This is where feature engineering, hyperparameter optimization, a lot of things comes into picture, and where you create a model which will be able to predict whether a customer is going to be churned or not churned. As simple as that. Now this step is engaging and acting. Now, what is engaging and acting? Once you understand the type of customers, then you probably build some recommendation engine, or probably you try to do some clustering techniques to understand which category do they fall in? Okay, I know that these 1,000 customers are going to be churned, but out of these 1,000, which categories are they falling in? Are they conditionally loyal? Are they conditional churners? Are they lifestyle migrators? So these kind of things you do in your engaging and acting, and you also get in touch with your sales department, to your higher management, to understand that what needs to be done. Because obviously as a data scientist I don't have the authority to give a 200 rupees plan for the customers. Like let's say I have 1,000 customers, I don't have the authority that let's give a 200 rupees plan for all these 1,000 customers and let's retain them. No, that's not with me. There is a lot of impact which needs to be done. Okay, revenue of impact needs to be calculated, and we need to calculate what is the customer value, what is the customer adding. Like let's say customer values we have to calculate what is his current plans. A lot of calculations are required here, and that's where you engage and act here. Okay. uh any other questions? I am working in automation domain. Any personal doubts, guys? Sanjeev, please connect me on LinkedIn. I will try to answer anything related to this particular session. Just feel free to leave a comment in the chat box. Does webinar include predicting outliers? I think I answered that. Okay, I don't know. Hello, sir. I just have completed learning Python. Can you guide me? Yes, I will try to help you out. Okay, so these are the areas from where you start collecting data. Now, obviously, if you don't have the domain knowledge, you might not be able to do that. Okay, guys who are watching this video, please try to like this video at least, because the more likes I get, YouTube starts recommending it to other people as well. So that helps. Okay. So data from various sources are aggregated. Now this is where your domain knowledge comes into picture. Then you will have an understanding what are the types of data which we can collect. We can collect the customer related data. We can collect the customer demographics data, like whether let's say he's living in Mumbai, in Hyderabad, in North India, South India, wherever he is living. What are the usage and the reload data? How often he is recharging? What is the usage? Is he talking more in the night? Is he talking more in the day? All this kind of data. Customer segment or campaign data. A lot of campaigns are also being run by a lot of companies, like a lot of telecom companies. So these kind of campaign data can also help you. SR data is nothing but service related data. Let's say complaint data, or let's say the sentiment analysis of the voice records. Let's say you are trying to call the customer care. Now only when you are not happy, it's a normal tendency, right? Even me, I don't, because if you are happy with the features and all those things, why would a customer call the customer care, right? So customer calls the customer care only when he's not happy. So when he's not happy, those kind of data can also be helpful for the predictive model building. Okay. And there could be some external data as well, let's say competitor analysis or kind of satisfaction surveys. So this is where you combine the data and then get started with it. Okay, I'll not try to go ahead and explain all this because this includes the end-to-end data science part as well. We are just focused on the on the EDA part, so I will quickly jump into the EDA slides. Okay, little more theory is required, and then we will have some good explanation, so it will be very interactive as well. Okay, so exploratory data analysis. Again, yeah, I mean, this is a separate slide, so this is going to be the agenda for this particular slide. We'll try to understand what is ADA, why ADA is important, what are the different visualization charts which are available, and which chart to use in which scenario. What are the different steps involved in ADA? And we will also discuss about one of the use cases. Okay, now EDA, you can see this is the reality and the raw data is being collected. So data is collected, then processed, and then the cleaning happens, and then your EDA performance EDA is done on that data, the clean data. And after your EDA is done, EDA basically gives you an insights, right? It tells you that okay, these are the category of people who are probably churning. Okay, only when you know that, then it will be easier for you to create. Anim, please don't spam. Connect me on LinkedIn. I'll try to help you out. Don't spam in the live chat, please. EDA. Once you once you do the EDA, once you understand that these are the insights are we are getting from the data, only then the data scientist comes into the picture, and then he starts giving, either he creates or the machine learning engineer creates, but ultimately after the EDA process, then you create the models and algorithms. Okay, so this is the entire data science process. Now, what is EDA? It is an approach to analyze the data to summarize their main characteristics in form of visual methods. Okay, EDA is nothing but a data exploration technique to understand various aspects of data. The main aim of EDA is to obtain confidence in a data to an extent where we are ready to engage a machine learning model. Very important point, because people might ask that already we are doing feature engineering and all these feature selection steps in the machine learning part. Why EDA is important? I hope you got the answer. EDA is to obtain confidence in a data to an extent where we are ready to engage a machine learning model. And Anim world, please don't spam. Uh, Thank you. EDA is very important to analyze the data. It's a first step in the data analysis process. It gives a basic idea to understand the data, blah, blah, blah. A lot of theoretical part is there. EDA helps us to identify the errors, discovering data, mapping out data structure, finding out anomalies, and finding out missing values. A lot of things. It is very helpful, right? It is important for business process because we are preparing data set for deep, thorough analysis that will detect your business problem. So visualization is the presentation of the data. A lot of theoretical thing is there. I will try to give this particular slide to you so that you can go through it. Just give me 1 second, guys. Sorry, I had to hide your message NM because you are spamming. So these are some of the important chats for visualization. Very quickly we will go through this because many of you might be bored, but yeah, I mean, ultimately if you want to understand everything in detail, then probably we'll have to go through this like one by one, right? We cannot directly jump into the code part. Many people, I have seen many people who are entering the data science and the analytics domain, they are, I mean, I don't want to hurt anybody's sentiments, but I have seen many people are just copy pasting the Kaggle data sets or copy pasting it from GitHub repositories, writing out the resumes, and then going for interviews. That's not how it works, because directly copy pasting the code doesn't give you any hands-on experience or gives you any knowledge, because you have to work end to end. You have to understand the use case, and then that's where you understand everything, right? So these are some of the important charts for visualization. Histograms, it represents the frequency distribution of the data. Okay, bar charts. Bar chart represent the total observation in the data for a particular category. We will see how bar charts and histograms are used when it comes to the coding part. Box plots. Box plots distribution, basically it is very much helpful because it has a lot of things to help you out. It gives you the minimum value, it gives you the maximum value in the data. First quartile, that is Q1, third quartile, that is Q3, and it also gives you median. Okay, it also gives you IQR, which is nothing but interquartile range. Okay. Pie chart, many of you might already be knowing pie chart. What exactly is pie chart? It gives you a distribution out of 100%, right? Let's say number of runs scored by the 11 players of your team. Obviously, if you draw a pie chart, it will sum, your sum total value will be 100%. So it shows you the percentage of 3, percentage of 1, percentage of 8 in a pie chart, right? Pie chart represent the percentage of the data by each category. Many people know about pie charts. Pair plots, basically pair plots are used when you are trying to do some kind of bivariate distribution of the data sets, but you have multiple columns to deal with. So in that case, what happens, you can make use of pair plots. So it basically shows the pairwise relationship between the variables. Scatter plot, when you are trying to analyze two numerical columns and you want to see how the distribution looks like and all those things, you want to see how the correlation is between the two variables, probably scatter plots can be used. Scatter plot represent the relationship between two numerical variables. Okay, can you explain the parts of the box chart? So if you go back to the box plot, this is going to be the minimum value. Box plot basically shows you five fundamental things. Okay, now what are those five fundamental things? It gives you the minimum value of the data. It gives you the maximum value of the data. It gives you the Q1 data, which is nothing but the first quartile, or you can also call it as 25th percentile. Okay, it also gives you the 75th percentile data, which is nothing but this one. This is your 25, and this is your median value, the middle line. Okay, and this entire blue area is nothing but IQR. IQR is interquartile range. Okay, this is minimum, this is maximum, this is your Q1, this is Q3, and this is your median value. Okay, scatter plots, I already explained. The scatter plot represents the relationship between two numerical variables. It shows the correlation between two variables. Now you can see, looking at this particular chart, I can see that I'm not pretty sure. Okay, this is tip. So y-axis we have tip and total bill. You can see the total bill increases. I cannot tell that it is linearly increasing, but I can see an increase in the values of tips as well when it comes to the total bill. So total bill increases, the tip also increases. Okay, Violin chart. Violin charts also are also used to plot numeric data. Inside your Violin chart, if you, I'm not pretty sure, I cannot zoom it, but inside a Violin chart you can see a box plots as well. You can, I mean, it's up to you how to use it, but you can either do a box plot or you can also do Violin chart. I'll try to see if I have Violin chart examples in the data as well. And line charts. Now line chart is nothing but it is used to track change over line and short period of time. So you can use area chart or you can choose line charts as well if you want to see the trend. Okay, line charts are mostly used in time series data so that we can understand the trend, if it is increasing or decreasing or something like that. Okay, so box plot versus violin plot. Okay, I have it covered. I didn't knew that I have this slide. So violin graphs are better than box plots. You can see this is the raw data. This is how a box plot looks like. Now you can see the box plot is almost same for these kind of data, but you can see the violin charts are different for this data. So this is why it is considered that violin charts are better than box plots, and they are also visually more appealing as compared to the box plots. How can we get this PPT? Please like the video. No, anyways, I was just kidding. I will also share the presentations to all of you. I will provide the link in the description below as well, or else probably in the pinned comment. After this session I'll quickly give you all these materials. But yeah, I'm seeing 43 people watching, but I don't see enough likes on this video. Guys, please like so that I will be motivated. And next one is strip plot. Strip plots are used to draw a scatter plot for the categorical variables on a categorical basis. Heat maps. Many of you might also be using heat maps. Heat maps is it's a data analysis software that uses color the way a bar graph uses height and width. Many of you might also be knowing about the correlation function. When we try to analyze multiple numerical variables, then we try to see what is the correlation between the numerical variables. If you don't know, correlation is nothing but it probably gives you a score between a -1 to 1, where near to 1 basically means that two numerical variables are linearly correlated, and if one variable increases, the second variable also increases. If it is near to 0, probably within the range of zero point 0.2 to -0.2, point 0.2, then it says that your numerical variable x and numerical variable y are not correlated with each other. If it is -1 or very near to -1, then it is inversely correlated. That means numerical variable 1 increases, then numerical variable 2 decreases. And that correlation function, you can use it in a heat map so that you can visualize it properly and see what, like, which variables are more correlated to each other. You can see this particular chart. I cannot zoom it, but this, where my cursor is, you can see 0.7. That means this particular column and this particular column are highly correlated. 0.7 correlation. That means if variable 1 increases, if this variable increases, this variable also increases. Okay, So when it comes to your numerical analysis, yes, heat maps plays a very vital role. So these are going to be some of the steps involved in EDA. Hardly 10 minutes left for the theoretical part, then we will go into the practicals. Which software you are using to present it? Ticker below is cool. I'm not pretty sure. Uh, okay, so these are the steps involved in EDA. First step is going to be data sourcing. Okay, data sourcing means what is the source of the data. We have to understand where we have to fetch the data. In startups, yes, databases are managed by just one team. You can probably get in touch with them and say that, hey, I'm going to do some analysis on these areas. Probably can you give me the access to the data? And yes, they will give you the access to the data. They might need your manager's approval as well, but that's going to be very easy. But when it comes to MNCs, people who are working in MNCs, they might be knowing that databases are not managed by just one team, right? So you have to get in touch with multiple teams, and that's where you have to collect the data, and that's where you're more like it's going to be very painful process. So people who are not exposed to the live data sets, who are using Kaggle, they might not know the pain of this particular step, because in Kaggle we already are getting the data sets in a very structured manner. We are just picking it, calling random forest, and creating models. So it doesn't happen that way when it comes to real industries. Okay, data sourcing, data cleaning, these are the two areas where we invest a lot of time when it comes to live implementations. Data cleaning is also a very pain in the ass. In data cleaning, we have to analyze what are the important columns, where we have missing values, and all these things. A lot of things happens in this data cleaning part. I'll show you when it comes to the coding part. Then comes your categorical analysis. Univariate analysis with visualization will I will give you examples and explain what is univariate analysis, what is bivariate analysis. We also have multivariate analysis, which I haven't covered here, but yeah, you can imagine how it should work. Derived metrics. We'll also talk about derived metrics as well. Okay, so let's quickly get started. I'll not go through these PPTs. We will directly jump into the like I usually love teaching on paint, so I will quickly jump into this. Using a live example, I'll try to explain what are the different techniques. Okay, first I will talk about the categorical analysis, and then I will talk about the numerical analysis. Okay, in case if I'm missing any topics, probably you just shoot, and I will try to cover it out. Okay, so customer churn. Okay, let's say I have this use case. I have customer ID, customer name, bandwidth, what else? Gender. I have geography or district, whatever you can call district, and I have contract type. I have X, I have Y, I have something else. Okay, no, I will not name it as Y. I will name it as X1 and X2, and then I have churn. Churn column basically tells me whether the customer has churned or not churned, something like that. Okay, I have customer IDs, let's say 1 2 3 4 5 dot dot dot. Customer name I'll not name, but yeah, something like Satya something 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 something. Bandwidth also some values. Okay, gender male, female, female, male, something like that. District probably Mumbai, Kolkata, Kolkata, Delhi, something like this. Customer type is sorry, contract type monthly customer, 1 yearly, 2 yearly, dot dot dot. So this is how the data set looks like. Okay, sir, please make a video on categorical data. So, luckily, I have a PPT for that also. Some of the data encoding techniques. So I'm going to release that video tomorrow. That video is almost ready, so I will release it tomorrow. Okay. Okay, so this is how the data looks like. The first thing is we have to analyze and discard those columns which are not relevant for the analysis. Okay, our everybody understand this, right? We have to analyze the churners. That means we have to analyze the customers, the characteristics of those customers. I will probably use a text box. Characteristics of customers that are going to be churned. Okay. Oh my god, my laptop is hanging. Nice. Just give me 2 minutes, guys. Okay. So this is our end goal. We have to identify the characteristics of customers that are going to be churned. So let's say I have 1,000 records. Okay. I wait. Okay. Let's say I have 1,000 records. So do we have to analyze the 1,000 records, or do we have to, let's say out of 1,000, just 200 have churned and 800 have not churned? We are clear about this use case. So what we need to do is, obviously we have to analyze the entire 1,000 records. But for the model building purpose, if we just analyze these customers, that's more than enough. If we try to understand the 200 customers, if we get the characteristics of these customers, then probably we can build a good model. Okay. So in order to do that, first thing is discarding the columns which are not applicable for this analysis. Okay. Now using my domain knowledge, I know that customer ID is a randomly generated integer. Does it have any impact in the use case? Can we tell that if the customer's ID is 2, then he is not going to be churned? If the customer ID is 3, he is going to be churned. So it doesn't make any relevancy, right? So that is the reason customer ID can be discarded. Similarly, customer names can also be discarded. Similarly, if there are some other columns, let's say x1, I know that x1 is not important. Let's say it has some arbitrary values, so we can ignore these columns as well. First step. Okay. Second step is, then we have to identify which of them are categorical variables, categorical columns, and which of them are numerical columns. Okay. So after this, noting down, the first step is going to be understanding the data distribution. Out of 1,000, 80 is to 20 ratio data is distributed. That means 80 non-churners, or you can call it as active, and 20% churners. Okay, that's the first intuition. Second intuition, customer ID, name, and x1 can be deleted. Okay, what is the third intuition? Then we go ahead and see how many columns are having missing values. Okay, there is a normal thumb rule. I mean, I cannot say that it's a thumb rule, but normally what happens is, let's say there are some columns. I will name such columns as, for example, I have column 1. Okay, let's say column 1 has, out of 1,000 records, it just has 600 records. 400 records are null, or not applicable, or null. So what people do is, most of the data scientists or data analysts, what they do is they try to ignore this column, they try to remove this column. Okay, but you can either remove it, or you can see if this column is impacted by some other column or not. One classic example is, let's say there is a column called as is car, and there is another column called as car type. Okay, I don't have my domain knowledge, like I don't know what this column is. I don't know what this column is. So it is going to be a very difficult problem statement for me to understand and see whether to delete this or not. Let's say Iskar. What is Iskar? Out of 1,000 customers, let's say 600 customers have car. So obviously there will be 600 Y records and 400 N records. As simple as that, right? Now people who don't have cars, whose value is N, car type basically tells you which type of car they have. Okay. Now people who don't have cars, obviously this column will have null values, right? That's quite obvious. People who have, yes, let's say SUV, XUV, something like that. Now, as a data scientist, if I know that this column and this column are related to each other, then I can probably understand why there are 40% null values here. So I will not remove this column. I will keep it for my analysis. Let's say what happens is in some of the banking sectors, we don't really see the column names. Sometimes the column names are, because of some non-disclosure agreements and all those things. In banking sectors, what happens is we deal with columns like x1, x2, x3, something like this. So in these cases, if I'm using x1, x2 and x3, I don't know that x1 and x2 are related to each other. In that case, probably I can delete this column. But if I know that this column is related to this column, I shouldn't delete it. Okay. So if there is no relevance for column 1 with respect to any other columns and it has 40% null values, then you can remove it. Some people remove only when they have more than 50% null values. Some people do it if they have more than 35% null values. There is no right or wrong, but it's just a thumb rule. Most of the people delete when they have more than 30% null values. Okay, let's say you have less than 35% or less than 30% null values. How to treat this? Our fourth step is treating missing values. Try to understand the steps of EDA. First step is understanding the data distribution. Second step is discarding the irrelevant columns. Third step is going to be again seeing which are the columns where we have more null values, which are the rows we have null values. And fourth step is going to be treatment of the missing values. Okay, where is my cursor? Okay, here. Now treatment of missing values. Let's say I have a column called as age. Age is a numerical variable. So let's say I have 15, 16, 20, dash, 25, 15. Okay. There are multiple ways where you can treat the missing values. Some people, what they do is they just simply take the mean value and impute the mean value here. So in that case, it will be 15 plus 16 plus 20 plus 25 plus 15 divided by 5. Okay. Whatever the value will be, they will just add it here. Some people, what they do is they take rolling window or moving average. Let's say moving average of window size 3. Uh, for this particular example, you will not be able to understand. Let's say 10, 12, 14, 5, 6 and null. Now what they do is, let's say they take a rolling mean value. So rolling mean of window size 3 basically gives you 10 plus 12 plus 14 by 3, whatever it is. Rolling mean. So this rolling bin you can populate here. Some people, what they do is they take this value, they do a time series forecasting. Okay, and then fill this missing value. Let's say after this missing value, the second missing value is here, 12, 14 and here. So you take this time series, predict it and fill it. After filling it up, you take this time series, predict it and fill it. Obviously it is going to be a very headache process, but you can do it. Okay, there is no right or wrong. Everything is hit and trial in machine learning or data analysis. You have to try and then you have to see whether your model is improvising, it is increasing, the accuracy is increasing or not. If not, then probably you come back to the step again and do something else. Okay. When it comes to categorical variables, let's say you have gender, male, female, something like that. So you can also take the mode value. What is mode value? What is mode? Let's say I have 5 values, F, F, M, F, F. So here the mode will be F because I have 4 instances where F are present and 1 instance where male is present. So if I have a null value, I will simply impute it as F. Okay. So there are multiple techniques where you can treat the missing values. After your missing values are treated, then comes your categorical analysis. CAT analysis. Now, what is CAT analysis? There are multiple things under categorical analysis. One is univariate analysis. Univariate. Second one is bivariate analysis. Bivariate analysis. Okay. And we have multivariate analysis. So univariate basically means uni means one variable. We have to analyze one variable. Guys, I'll be back in 1 minute. I just need some water. In case you have any questions, just feel free to comment out in the live chat. I will quickly be back in 1 minute. Okay, okay. I don't want to lose viewers. People will drop. Okay, univariate analysis. I'm not pretty sure why I'm still able to see. Okay, now. Okay. My video was not getting refreshed, so I was still seeing 9 likes on the video. Now I can see. Now I can see 64 likes. Okay, thank you. One dislike. Okay, that's fine. Univariate analysis is analyzing one single variable. Now let's say I talked about the data set, right? I have 1,000 records. 200 are churners and 800 are active customers. So from this, I will try to analyze. We know from the initial data set, the ratio distribution is 20 is to 80%. Okay. Out of 200 records, what is the distribution of male and female? That's the main question. Let's say 105 are male and 95 are female. So how many males? What is the male ratio? Probably 51% and 49% females, which is almost like equal, like 50-50, which is okay. I cannot tell that there are more males as compared to females. Okay. The second thing is, let's say contract type. I have monthly contract, I have 1 yearly contracts, and I have 2 yearly contracts. Let's see what is the distribution of them. Obviously you have to also analyze that what is the initial distribution of the data. Out of 1,000 records, how many are males? Let's say I'm just taking a rough example. 500 males and 500 females. Let's say I have even distribution. Okay, in that case I don't find any insights, because 51% males have churned and 49% females have churned, which is kind of okay. Okay, if I take the ratio with respect to the original data, 105 divided by 500, how much? 21% and 19%. So the original distribution was just 20%, right? 20% of the people have churned. So I don't find any much insights from this. Monthly, yearly, and 2 yearly. Monthly, let's say I have 100 people. Yearly, I have 60, and 2 yearly, I have 40. So here I can see that almost 50% of the churners are monthly customers. Almost 30% of the people are 1 yearly customers, and almost 20% are 2 yearly customers. Now, in the initial data, out of 1,000 records, how many are 1 month, how many are 1 year customers, and how many are 2 yearly customers? That we have to see. Okay, because this distribution is just with respect to the contract type. We have to also analyze what is the distribution in the original data, right? Let's say out of 1,000 records, just 200 records are monthly customers, 500 records are yearly customers, and 300 customers are 2 yearly customers. So out of 200, 100 customers have churned, monthly customers. So what will be the ratio? 50% ratio. Out of 1 yearly, out of 500, just 60 have churned. How much? Just 11% people have churned. Out of 300, 40 people have churned. So somewhere around 12% or 30% people have churned. So here we can see that more 1 year, 1 monthly customers have churned. That means people who don't have contracts are free to go. Can you give some more examples of type of distributions checking? I'm not pretty sure, Mukut. What's your question? Uh, Probably I'm not pretty sure. Maybe you can write more. If you can explain, probably I will try to see if I can understand. Okay. So the thumb rule is that we have to analyze the original data and then we have to analyze one variable by one variable. Okay, now you can see that in the original data, 200 records were monthly customers, 500 records were 1 yearly customers, and 300 customers are 2 yearly customers. Out of 200, how many have churned? 100. What is the ratio? 50% of the total population have churned. 500, what will be the ratio? If I calculate 60 divided by how much? 300, right? Sorry, 500. Almost 12%. 12% people have churned. And 40 divided by 300 into 100, 13%. 13%. So you can see the original data, we know that the original distribution are 20%. 20% of the people have churned. Right. Here we can see monthly customers are more likely to churn. So one of the important insights which we get from here is monthly customers are more likely to churn. And one more insight is that 1 yearly and 2 yearly customers are less likely to churn. That means tomorrow, if a new customer comes in, if he is having a monthly contract type, then his chances of churning will be more. The model will automatically understand and give more score to that customer that this candidate is going to be churned. Okay. Similarly, we have to analyze all other columns as well. Let me just expand it, guys. Okay. Similarly, we have to analyze other columns as well. So this is how your univariate analysis comes. Next comes your bivariate. Bivariate. Okay. Let's try to understand bivariate obviously means analyzing two variables, right? So let's say gender plus contract type. Now, obviously, if you have 10 variables, you have to do analysis like that. A with B, A with C, A with D. A lot of analysis needs to be done, and then you can come into a final conclusion. Okay. So we are just analyzing gender plus contract type. So in the original data, let's say I have 500 males and 500 females. Out of 500 males, how many were contract type? One second, 200, 500, 300. So contract type 200, 500, and 300. I will just evenly distribute it so that we understand better. So monthly customers, I have 100 and I have 100 here. 1 yearly customers, I have 300 here and 200 here. 2 yearly customers, I will have 150 and 150. Okay, randomly I have distributed. Okay, so out of here, this is my male and this is my female. Out of here, out of 200, we will see how many have churned. Let's say 105 have churned, right? And 95 females have churned. Now I will try to see out of 105, how many are monthly, how many are 1 yearly, and how many are 2 yearly. Let's say in monthly, I have 75. I have 20 and I have 95, 10. Okay. Out of 95, let's say 40. And here, how much? Let's say 40. And here, let's say 80, 15. Okay. So from here, you can see that out of 105 males, 75 have churned. See, the ratio here is very high. So one of the insights is that males plus monthly customers are more likely to churn. Similarly, females with 1 yearly customers are more likely to churn. Females. So there will be new insights which you will get once you start analyzing multiple variables. Okay, univariate analysis will give you some insights, some initial insights, but obviously they are not the final insights. You always have to dig in and analyze by variables, like two variables. That's where you come into conclusion. Okay. Similarly, one more insight is that 2 yearly customers are very less likely to churn. Okay. Similarly, we have to analyze hit and trial. You have to analyze each and every combinations of the variables, and then you come to a conclusion. Then comes your multivariate analysis. Multivariate analysis, I haven't seen many people doing it, but in some of my use cases, I have done it in some of my previous companies as well. So again, when you have enough time for ADA, then probably you can do it, but it's going to be very time taking, because if you have 10 variables, you can imagine how many combinations there will be, right? ABC, ABD, ABE, and it goes on, right? So multivariate analysis could be more than three variables analysis, right? So let's say gender plus contract type plus geography. Then you try to analyze that out of these males, out of these monthly customers, h- how is the distribution in Mumbai, in Delhi, in Hyderabad, and accordingly you analyze and finally come to conclusion. Okay, this is how your categorical analysis is done. Then might you might ask me that sometimes we also convert categorical data to numerical data, right? Because ultimately when we build models, once your EDA process is done, when you start building models, then comes your picture, because ultimately we have to feed numerical data to the models, right? We cannot feed categorical data to models. So we always have to convert categorical data to numericals. Okay, that's where your data encoding techniques comes into picture. Data encoding. I have a separate slide for that, data encoding techniques. I will quickly run through this, but I have a video coming tomorrow. Immediately you can watch out tomorrow at the same time. I will release it. Uh, this is basically tells you what are the different encoding types. How do you convert categorical data to numerical data? Okay, there are different techniques for that. Many of you might be knowing about label encoders and one hot encoders, right? But there are a lot of encoding techniques. We have label encoding, we have one hot encoding, we have dummy encoding, we have effect encoding, we have hash encoding, we have binary encoding, we have target encoding. So we'll talk about all these things in very concise manner, in a very short manner. But yeah, there will be a video coming in tomorrow, so you can go through this. Let us say we have large data set with too many outliers and too many missing values. So as EDA, what will you do first? Impute missing values or handle outliers? So first step is going to be analyzing the missing values. That's going to be the primary step. Okay. Once you analyze the missing values, then probably you go ahead and handle outliers. Okay. So we'll go ahead and try to see some of these basic encoding techniques, because it will be lengthy, but yes, let's see. Label encoding. Label encoding means, let's say I have let's say I have city, I have Mumbai, I have Kolkata, I have Delhi, I have Mumbai, something like that. Okay. So randomly you populate some numbers according to it. Let's say Mumbai is 1, Kolkata 2, Delhi 3, Mumbai 1, something like that. So if you do some sort of this label encoding, then what happens is, sometimes when you pass this data to the model mistreats this data and tries to prioritize these values. So it prioritizes Delhi over Mumbai. Sometimes it happens. So it is not recommended to go for level encoding. Okay. But in case you are dealing with ordinal data, for example, you have primary school, then you have secondary, then you have graduation, then you have post graduation, then you have PhD, something like that. In that case, you can do 1, 2, 3, 4, 5, something like that. Okay, when it comes to ordinal data. Okay, so but normally label encoding is used in the case of, normally we use it for the dependent variables only, the y variables. Okay, let's say I have churn and not churn, then I will mark it as 1, I will mark it as 0, something like that. Okay, the next step is going to be, if label encoding is not a right step, how to deal with these kind of columns? Second technique is one hot encoding. So city, Let's say I have customer ID 1, 2, 3, 4, 5. Let's say 6. City I have Mumbai, Kolkata, Delhi, Mumbai, Hyderabad, Kolkata, something like that. So what we do is we convert this column into multiple dummy variables. So let's say I have 1, 2, 3, 4. 4 variables. So my new output will be having 4 new dummy variables. City underscore Mumbai, city underscore Kolkata, city underscore Delhi, and city underscore, what was that, Hyderabad. Okay, so for first case it will be 1 0 0 0, k 0 1 0 0 0 0 1 0, Mumbai 1 0 0 0, and it goes on. Okay, for Hyderabad 0 0 0 1. Okay, something like that. So what you can do is you can remove this column and you can use these new columns which are in the forms of zeros and ones. Our next technique is going to be dummy encoding. What is dummy encoding? So in one hot encoding, the only drawback is that when we have 4 valid values, it creates 4 features. Okay, so there is a concept of dummy trap. Dummy trap. Okay, so what happens is basically if I am also ignoring this column, then also we are able to understand that, let's say for this Mumbai 1 0 0, that means obviously the next column will be 0, right? Because we already have 1 1. Hyderabad 0 0 0. So we already know that this is going to be 1. So even if you remove this column, it's not going to be impacting your model. So when we create dummy variables, we should always create n minus 1 dummy variables. So this is where your dummy encoding comes into picture. There is a method called as get dummies. You can make use of that and create your dummy variables. So when you create get dummies, you call your df.getDummies, drop last equals to true. That means you are trying to drop the last column. Similarly, what else other encoding techniques we have? Effect encoding. Now effect encoding is the extension of dummy encoding. Let's say your dummy encoding's output is going to be this one, these 3 columns, right? So effect encoding, what it does is whichever row has the entire 0 0 0, it converts it into minus 1, minus 1, minus 1, minus 1. So this is all about effect encoding. Now if you ask me why that, so this is how it has been created. We don't know which one of them might be actually good in terms of performance, in terms of model building, but we always have to do a hit and trial, and then we have to see which one is going to be more effective in that particular use case. Okay, it is also called as deviation encoding or sum encoding, almost similar to dummy encoding. Okay, and one more encoding is that hash encoding. I'll not try to explain it in right now, but yeah, I'll have the video coming in. Target encoding, binary encoding, a lot of things are there. Which is best? It all depends upon the scenario. But OHE, like one hot encoding, is mostly used, or you can call it as dummy encoding is mostly used. Whenever you have thousands of variables for a categorical column, you have to use your domain knowledge to cut down the number of variables. For example, now you would say that, let's say I have a column called as city. Okay. Now for this example, I just have 4 values. You might think that when it comes to real use cases, there could be multiple cities, right? It could be Mumbai, Delhi, Hyderabad, Bhubaneswar, something, something. There could be thousands of cities. Let's say 1,000 cities. Now, if I have to convert it into dummy encoding, I will have 999 new columns. Is it the right way to do it? Well, the answer is it's dicey, because I cannot tell you it's the right way to do it or not. Because if you are creating more features, your model runtime is going to be very high. Performance is going to be very low, because performance as in the code performance, as in because it will have more features, it will have more data. Your model will take more time to run. Okay, so is it the right way? You can probably do that and see how your model behaves. But one of the ways could be converting a categorical variable to another categorical variable using your domain knowledge. Okay. Now, for example, I will convert it into city underscore zone, something like that. Mumbai, I will mark it as south. I'm not pretty sure. Mumbai is west, right? West. Delhi, north. Hyderabad, south. Bhubaneswar, east. Something like that. Central, something like that. So right now, at least as compared to 1000, right now I have five valid values. And then if I convert it into get dummies or dummy encoding, I will have four features. So I am reducing the computation time for the model. Okay, these kind of things you have to use your domain knowledge. Sometimes we also have to convert numerical variables into categorical variables. Now, ultimately, we have to convert it into numericals only. But just imagine this thing: I have age or I have tenure. So, tenure means, let's say, age. Okay, somebody is having 11, 12, 21, 60, 50. Now, if I try to plot, let's see what is the age distribution with respect to churn. If I have to plot it, I will have to plot it from 1 to probably the maximum age we have, right? Let's say we have 100 as the maximum age. So, so many bar charts. It will be very confusing for us to understand how the pattern is. So, we can do one thing, we can create bins out of it. So, what is bins? Let's say we create 1 to 15, 16 to 30, 31 to 50, and 50 plus. Now we have four categories. Now, if I have to plot the data, this is how it looks like: 1 to 15, 16 to 30, 31 to 50, 50 plus. Okay, now we will be able to analyze. Okay, so people with 1 to 15 and 50 plus are more churning. And obviously, next step will be converting into numericals. So you again get use of your dummy encoding and create three columns out of it. So age 1 to 15, age 16 to 30, age 31 to 50. And this is how it goes on. Okay. Our next topic is going to be analyzing the numerical data. One second. Okay. Let me just go this way. Okay. So next step is going to be analyzing the numerical data. Numerical analysis. So when it comes to numerical analysis, heat map, there is something called as correlation. Okay. There is a core function. Okay. Inside pandas. But what does core function does? Core function is nothing but it creates the correlation of the linear variables. Now, correlation, as I already explained some time back, correlation is nothing but it tells you how the numerical variables are correlated with each other. Let's say I have a column called as age, then I have tenure, then I have monthly sales, then I have yearly sales, then I have bandwidth, something like that. So we have to analyze that, can we see a trend? If age is increasing, the monthly sales is also increasing. If age is increasing, bandwidth is also increasing. Let's say I try to plot it, age. So I can see that, so when age is increasing, bandwidth is not increasing. That means age and bandwidth are not related to each other. They are not correlated with each other. Let's say I try to plot age, something like this. So we can see once age is increasing, you can see age is increasing, your y variable is also increasing, your total sales is also increasing. That means your age and your total sales could be positively correlated. Let's say like this, that means negatively correlated. When your x is increasing, your y is also decreasing. Okay, something like that. So cat numerical analysis, we have to use the correlation function. Basically, if you have more than, if you have lot of columns, you cannot do this one by one, right? So we have to call the correlation function. It gives you everything. Let's say I have 10 numerical columns, so your final output will be something like this: column 1, column 2, column 3, column 4, column 5, dot dot dot, column 10. Similarly, column 1, column 2, column 10. So x axis also I have same columns, and y-axis also I have same columns. So if I have to draw this, this is how it looks like. Okay. Now this value will give me the score of column 1 is to column 2. And this is how you can get your range of the values will be between -1 to 1. Okay. If your score is very close to 1, that means positively correlated. If the score is near to 0, that means no correlation. If the score is near to -1, that means negatively correlated. And once you understand the correlation, then you can take the next steps. Okay, everybody clear? So what I drew here is it's a heat map. Okay, you can easily plot your correlation function and call it over a heat map. So this is about the basics of EDA. Let me go through the PPT once again if I have missed anything. And then we will go into the practical part. Data science process, EDA. EDA we understood, visualization, it's the presentation of the data, histograms, bar charts, box plots, pie chart, all these things we covered. Steps involved, I think we covered that. There are two major kind of data which can be classified according to the source, public data and private data. I don't have to explain these things. These are very basic things you can understand. The following are some steps involved in data cleaning. Somebody was asking, right, that let us say we have large data set and what should be the initial step. Your first step always has to be handling missing values. Okay, then standardization of the data, then comes your outlier treatment, then you have to handle invalid values. Okay, some questions you need to ask yourself about the data before cleaning the data. What you are reading, does it make sense? Does the data make sense? Does this data you are looking at match the column labels? After computing the summarization statistics for numerical data, does it make sense? Does the data follow the rules of for this field? All these questions comes into picture. Okay, handling missing values, I think overall I have covered everything, but I'll just go through this slide so that in case I have missed anything, you will just understand. Delete rows or columns. The method we commonly use to handle missing values. Rows can be deleted if it has insignificant number of missing values. Columns can be deleted if it has more than 75% missing values. Again, one disclaimer here is that I hope you understand that, right? If the column is not related to any other column, then you can probably delete it. Okay, if it has more missing values, but it is always advisable to seek your domain knowledge peers and see. Can you explain the feature scaling part as well, like differences between normalization and standardization? Okay, Abhishek, I'll teach. I'll also tell you that feature scaling is very important, guys. We'll talk about that. Okay, replacing with mean, median, or mode. I think most of you might already be knowing that mean, median, and mode. Okay, we can replace. Mode basically means to replace the categorical variables. You can replace the numerical variables with help of mean or median or ruling mean as well. Algorithm imputation. What is an algorithm imputation? Some machine learning algorithm supports to handle missing values in the data sets like KNN, naive Bayes, and random forest. So there are some algorithms which are actually useful and they can also take care of your missing values as well. Okay, predicting the missing values. I also told you that we can take help of time series forecasting models in order to identify and predict the values. Okay, that will also be helpful in predicting the values. Prediction model is one of the advanced method to handle missing values. In the method, dataset with no missing values become training set and dataset with missing values become your test set, and missing values is treated as target variable. Okay. So example, I don't have to explain the examples. Standardization or feature scaling. Now, feature scaling is the method to rescale the values. Okay. I will again have to go back to my paintbrush because I usually take help of pen to explain everything. Now, what is feature scaling? Before you understand what is normalization and standardization, try to understand what is feature scaling. Okay. Now, I cannot interact with you all, but I think you will get it. Okay. So let's say I have a column called as weight. Okay. 75, 80, 65, 55, 90, etc. etc. Okay, as a human being, we already know what type of scales are present, right? We know weights could be in lbs, it could be in kgs as well. So here I can probably think and know that it is in kgs. Okay, so it's a human tendency. We know because we have been trained, because humans are nothing but we are also kind of machine learning models, right? We have been trained with a lot of data, right? So using my experience, I can say that this is in kg. But how will computers understand if it is in kg or if it is in lbs? Okay, so we always have to normalize the data. We always have to scale it down to a certain scale so that the computers don't, you know, what they do is when I feed this data to the computers, they don't know it is in kgs or lbs or anything, right? So it is high, there are high chances that it will give more priorities to the higher values and less priorities to the lower values. So it is always recommended to scale it down. Now let's say my weight is in lbs. Okay, probably I'll take the help of height. It will be more relevant. Let's say I have height 175, 172, 179, 180. Okay, I know this is in centimeters. Now let's say there is a new, let's say I have height in meters. 1.75, 1.72, 1.79. So how will machine learning models understand which column is in which scale? So we always have to scale it down. It could be within a scale of range of 1 0 to 1. It could be within a range of -1 to 1. There are multiple scaling techniques as well. Mean normalization and mean max scaler. A lot of techniques are there. Okay, I will just talk about the basic technique. So the basic technique is that, let's say I divide this value with respect to the highest value. 175 divided by 180. What will be the output? Somewhere around 9 point something, right? 9.7, 0.97. This one will be, let's say, 0.95. This one will be 0.99. This one will be 1. Similarly, this column, I will also be doing the same thing. I will be dividing it with the highest value. 0.97, 0.95, 0.99, and 1.00. You can see that these two columns, they were having different values, right? It is 175, this is 1.75, but when we are scaling it down, the final output is same, whether it is in cms or whether it is in meters. So it is always recommended to convert the data into, like, we have to always scale it down before passing the data to the models. So always you do feature scaling and then pass the data to the model. So whenever there is a new data comes in, you always have to do the scaling thing and then you have to feed the data to the model. Okay, so we'll try to understand the different types of feature scaling. Okay, importance of feature scaling: when we are dealing with independent variables or features that differ from each other in terms of range of values or units, then we have to normalize or standardize the data so that the difference in range of values doesn't affect the outcome of the data. Okay, now what is standardization? Standard scaler is very commonly used, like even I use. Okay, standard scaler ensures that each feature, the mean is 0 and the standard deviation is 1, bringing all feature to the same magnitude. In simple words, standardization helps you to scale down your feature based on the standard normal distribution. Okay, so the formula for this is, let's say, so you can see this formula. Z is nothing but x minus mu divided by sigma. Sigma is your standard deviation. Mu is your mean. Okay, and x is your original value. Let's say 175. Okay, so let's say here I'll take the same example: 175, 170, what was that, 172, 179, and 180. So what will be the mean of this value? I will have to calculate. It will be taking a lot of time. Okay, you can calculate that. You have to calculate your mean value. Okay, this divided by 4, you have to calculate the standard deviation, and then you have to calculate the z-score for each and every values. And these values are nothing but the standardized values. You can use it in the model. If you ask me, is it the most efficient way? Again, simple answer, there is no right or wrong. You have to do a hit and trial. Okay, you have to start trying with standard scalars, then you probably switch to normalization or min max scalar. You have to do a hit and trial. Okay, so min max scalar is nothing but it's a normalization technique. Normalization helps you to scale down your features between a range of 0 to 1. Okay, standardization, the formula is z equals to z or else the new value. I'll write it as x dash equals to x minus mu by sigma. So normalization, you can see x minus x mean divided by max minus x mean. So x minus x mean divided by x max minus x min. Okay, so for this value, it will be 175 minus x min 172 divided by 180 minus 172. If you just write it down, your output will be 3 divided by 8, 0.375. So it is always within the range of 0 to 1, your normalization. Okay, so this is the difference between normalization and standardization. Example, yes, it's the same example. I have already talked about one of the examples, right? So normalization, income minimum 12,000, income maximum 30,000. Hence we have converted the income values between zeros and ones. So 0.16, 0, 1, and here your average is taken, your standard deviation, and you calculate the values. Okay, outlier treatment. Now comes your outlier treatment. Somebody was asking how to treat outliers. A lot of techniques are there to treat outliers. There are also anomaly detection algorithms which you can use, but there are also simple visualization techniques which you can use and identify the outliers. Okay, outliers, simple terms are the I think I think you might need some break because it's almost a lot of time where we haven't taken break. Let's take quickly 2 minutes break. I'll be back in 2 minutes. What is the time right now? I'll quickly be back by 8:30. I think it's 8:30. Yeah, I'll be back in 2 minutes. Okay. You also can have water and quickly be back by 8:30. Okay, I'm back. Let others be back as well. In case anybody has any questions, guys, just write down in the live chat. Oh my god, 85 likes. That's amazing. Thank you all. These days, the YouTube recommendation engines have changed, the YouTube algorithms have changed. So it's very difficult for people like me to grow on YouTube. Of course, I'm growing very good in my parallel universe, but yes, on YouTube, it's really difficult to grow. But it's okay. We'll go slow. We'll try to grow very slowly. That's not a problem. I hope everybody is back. Let's quickly get started. So outlier treatment, in case you don't know what are outliers, outliers are some points which lies very far away from the normal distribution. Let's say I have data like this, and most of my data is somewhere here. And let's say some of the data is here, is here, is here. Then You can call it as outliers as well. Okay. Okay, on outliers analysis and anomaly detection, I cannot finish entire thing in just 5 minutes because anomaly detection itself is very huge. I will try to keep a session on that. Not pretty sure if people will join or not because that's going to be a little bit boring, but it's a very important topic, so we'll keep that session for one of our future classes. I will talk anomaly detection in depth. Okay, what to do, what not to do, what are the different anomaly detection algorithms, how to, because see, anomaly detection is not very simple. You cannot just, this is just anomaly which is visible by human eyes. There could be other anomalies within the data as well. Let's say, I cannot give you an example. Let's say something like this, the data is increasing, something like this. So obviously this is an anomaly, this is an anomaly, and this is an anomaly. Okay, that it is quite visible from the human eyes. But this could also be an anomaly. If you look at the range of the areas of the data points, it could also be an anomaly. We don't know. Okay, similarly, this could also be an anomaly. So anomaly detection is very wide. It's very difficult to do anomaly detection and then use it in the models. But I will try to have a 2 hour session on that. I will keep you all notified. So in case you want to get notified, just subscribe the channel and hit the bell icon. Okay. I'll try to plan some topics, plan some sessions on anomaly detection. Okay. But the general concepts, let's try to understand that. So detecting anomaly outliers using following methods: box plots, histograms, scatter plots, and using z-scores. Z-scores means the standardization techniques, and IQ or range, interquartile range as well. Okay, how to handle outliers? There are multiple ways to handle outliers. You can either remove them or you can replace them with some mean values or median values or some quartile methods or some interquartile ranges, or you can probably use some machine learning models which are not sensitive to outliers. So there are multiple ways to deal with it. Okay, I can just give you one example or two examples, but when it comes to real implementation, you will have more understanding on that. What is hyperparameter tuning, Roshan? When you create a model, let's say after your EDA step is done, so first comes your EDA. After your EDA is done, you get the insights. Then you start creating models. Okay. Now when you start creating models, you don't create just one model, right? You create multiple models. Model one, model two, model three. This could be a random forest. This could be a neural ANN. This could be a decision tree. And then you see which model is giving you best accuracies, right? For example, your XGBoost or random forest are giving you best accuracies as compared to other models. So what you do is you go ahead and you take this model and try to do hyperparameter tuning. Now, what are hyperparameters? In your models, when you are calling your random forest, let's say there is a parameter called as entries, and there are some multiple other parameters as well. Okay, random state, lot of things are there. So whenever you call this, these are called as your parameters, and we really don't know what is the best value of this. For this model building, I have arbitrarily used the value as 100, but we don't know if 100 is the best value or 200 or 1000. So that's where your hyperparameter tuning comes into picture. After you get your initial model, then you try to tweak the parameters and try to enhance the model's accuracy. Okay, that is the main usage of hyperparameter optimization. Handle invalid values. There could be some encoding issues as well. Encode Unicode properly in case the data is being read as junk characters. Try to change encoding to UTF-8 or something else. Converting incorrect data types. A lot of these are some of the very common issues which happens. Okay, there could be some date mismatch. Your columns could be read as strings. You should convert it into dates, or your date formatting issues. It could be in Kelvin cycle. You are probably using Celsius cycles. So there are a lot of issues which happens with when it comes to invalid values. So you have to deal with it. Okay, correcting the invalid data types or correct values that go beyond range, or correcting the wrong structure. Okay. Then comes your univariate. I think I have covered this. Types of data I have covered. Discrete, continuous, these are the left side is for the numerical data, the right side is for the categorical data. Nominal is for like gender, male, female, or eye color, or geography. These are nominal data. Ordinal data is from increasing order or from decreasing order. Let's say primary, secondary, graduation, post graduation, PhD. That's going to be ordinal categorical data. In that case, you can probably use label encoders. Okay. Segmented univariate analysis, bivariate analysis. Derived metrics also I have explained. Derived metrics are when you derive some columns from some external columns. For example, I talked about age, right? So age is a column, is a numerical column. When we tried to analyze it over a bar chart, it was very difficult. So what we did is we converted the age into bins, right? So these are some derived metrics. So derived metrics create a new variable from the existing variable to get a insightful information from the data by analyzing the data. Sometimes you also have to convert some columns, like combine the columns. For example, I have a column called as year, I have a column called as month, and I have a column called as day. So these are three different columns. You can probably convert it into one column called as date and then convert it, right? And you can use this column. So this is going to be a derived metric. Okay. Uh, Vishwa, I'm not pretty sure what you're typing in. Just be careful. Unsupervised binning, equal width, equal frequency, entropy based. These are some of the other concepts. Feature encoding also I talked about, right? Label encoding, one hot encoding, dummy encoding. Obviously, I didn't cover target encoding and hash encoding. I'm just reminding you, I'm going to push one video tomorrow, which is going to be a 30 minutes video on these kind of feature encodings. Okay. How to deal with encoding issues. So we'll cover that and use cases. So today's topic is almost over. We'll directly jump into the coding part. Obviously, I'll not do coding in front of you. So because if I do that, it will take more than 2 to 3 hours to finish. So I already have the code ready. I will try to quickly run it or probably show you and leave this code to you so that you can run it by yourself and try to understand. Sir, give me full explanation in EDA. You are misleading from today's agenda. Please answer only EDA. Okay, so everything, whatever I'm explaining, it's EDA only because first I explained about the use case and then I explained about EDA. So where have I deviated from the topic? Everything which is taught in today's video is related to EDA. Outlier, if you are telling outlier detection is not EDA, it's EDA. It's a part of EDA. Aishwarya, I'm not pretty sure where your question is. Can you probably type in your question again, Aishwarya? Okay, great session. Thank you. Could you please tell me difference between normalization and standardization? I think I covered it, Aishwarya. I'm not pretty sure if you joined recently or not, but I have already covered it. I will just quickly give you a heads up again. But yeah, you can, after the session is over, you can check the video again. I have explained it. Okay. Where can I access all your videos? Salman, everything is there in my YouTube channel. I think most of it are already a part of my YouTube channel, so you can check it out. Obviously, I don't have end-to-end machine learning or statistics videos, but I do have data analysis, EDA, and Power BI, these kind of videos as well. Okay. Standardization and normalization. So these are one of the two techniques for feature scaling. Okay, standardization is nothing but when you try to standardize the data with respect to, so basically with respect to the normal distribution, you have there is a concept of Z score. Okay, again, if I have to explain you Z score, it will take a lot of time to explain, but just try to understand that these two, standardization and normalization, are two different feature scaling technique. Okay, standardization basically ensures that for each feature the mean is 0. Okay, and the standard deviation is 1. That's the assumption which it has, bringing all the features to the same magnitude. In simple words, standardization helps you to scale down your features based on the standard normal distribution. Okay, so you have to calculate the mean. Let's say you have values like 100, 200, 150, 120. First of all, you have to calculate the mean. Then you have to calculate the standard deviation. And then you can calculate the Z score for each values. And those Z scores are basically your final standardized values. When it comes to normalization, it is basically your x minus x mean divided by x max minus x mean. So it always does the values between 0 to 1. Okay. Gopi, I'm not pretty sure if if you have attended the session end to end or not. I think I have explained univariate and bivariate everything. But yeah, let's go back to the coding part and try to see if you are able to get it. Okay. Anybody has any doubts related to the univariate analysis or bivariate analysis? Because I tried to answer as much as possible. I tried to explain as much as possible, but okay. In case Gopi, you have any questions, probably you can ask me later on. You can connect me on LinkedIn. I will try to help you out. Okay. For applying z-score to any feature, does that feature needs to be normally distributed? Yes, the feature needs to be normally distributed. Okay. So let's go back to the coding part. Here, probably Gopi will have more understanding on this because line by line I have explained everything. Okay. So here I will not run this code, but I will just quickly do a code walkthrough and then you can take this code, run line by line. Okay, line by line you run it and you will get it. You will understand what I am doing. And whenever you have a EDA task tomorrow, let's say you are working on some EDA use case for some other analysis, you can directly reuse this code. You just have to tweak the code. You just have to do some minor changes. That's it. Okay, but the idea remains the same. So dataset info, this is a sample dataset containing teleco churn data. I will also send you the dataset. Okay, I'm reading the data. Here I am doing the head. So these are the basic things which we do, head, tail, and all these things to see how the data looks like. I have customer ID, gender, senior citizen, partner, dependents, a lot of things, multiple lines, internet service, lot of things. Then I'm doing dot shape. Dot shape basically tells me how many rows and how many columns do we have. Okay, these are the basic EDA steps. Okay, you have to do these things. There are some other techniques to know the total columns as total rows as well. I have also commented it out, but you can run it. You can do length of data frame. Okay, you can get the number of rows. Data frame dot column dot values will give you the total number of columns, which all columns you have and all those things. Then we have to type in d types. D types will tell you what is the data type of that particular column. If this is object, you can probably convert it into strings. If something is not, let's say for example, monthly charges or total charges is in object. So obviously we have to convert this into integer or float, or else you will not be able to analyze it. Okay, so d types it gives you an internal intuition what are the data types currently. Okay, because when we are reading the data from Excel sheets or from some databases, most of the times it pandas doesn't really understand what is the data type of that particular column. Okay, so it takes it as object data type. Dot describe basically gives you the descriptive statistics of the numerical variables. Now, if your question will be why just three columns? Because here in the data types, you can see I just have three integer columns, three integer and float columns. So my output is just for those kind of things. If I convert these values to numerical variables and then call this describe method, then I'll have it for the entire columns. Okay, this basically gives you an internal intuition. What is the count? What is the mean value? What is the standard deviation? What is the 25 percentile value, 50 percentile value, and 75 percentile value? Okay, you can see the average monthly charges are 65 USD. Okay, the average monthly charges. Whereas 25% customers pay more than 89. You can see more than 89, 25 customers are paying. What is the mean value? 65%, 65 USD. Okay. More than 50% of the people are paying $70. Okay, and the maximum is 118. Then I'm plotting the data with respect to the churn column because I have to identify what is the distribution of my churn column, because I'm dealing with a churn analysis, right? If I have 1,000 records, out of 1,000, what is the distribution? How many are churned? How many are active? Basically, for that, you can simply call your value counts method as well. It will also give you the output. Let me run this code. Okay, it will take one more minute to finish. So simply, if you want to see the distribution, you can easily take help of the value counts method and it will give you the distribution. But in case you want to do some visualization out of it, you can plot it using a bar h. Okay, 2 more minutes. Let it finish. Okay, in the meanwhile, we'll proceed. So here I'm just plotting it. I have just given a x label, which is my x-axis. What I'm going to print in the x-axis count, and y-axis I am having the target variable, and I have a title of the plot. Okay, it looks little bit complicated, but it is not complicated. Okay, you can see, if you simply have to see the distribution, this is how the distribution looks like. Okay, 5,174 are active customers and 1,800 inactive customers. Okay, but if I have to see the distribution as in what is the percentage distribution, what I have done is some same thing divided by the total length. Okay, I have converted same thing divided by the total length into 100. This is telling me 73% people are not churned, 26% people are churned. Okay, this gives you an initial idea. And then again I am plotting the data. That's it. And you can see data is highly imbalanced, 73 is to 27 ratio. How can I access this code? I will send you this code, not an issue, Vicky. Thank you, Mohit. Thank you. So after we get this initial intuition, then we know that, okay, this is a highly imbalanced data. Okay, so we analyze the data with other features while taking the target value separately to get some more insights. Okay, now if your question is how to deal with imbalancing data when it comes to model building, that's a very separate topic. I will not cover that in EDA. There are multiple uh, multiple ways to deal with a imbalanced data set, but here we are just concerned about EDA, so we will try to analyze the data. Okay, and when we analyze the data, our first focus should be on these 1869 records, because these are the customers who have churned. We want to understand that what is the category, what is the characteristics of these 1800 customers. Okay, uh, Arnab, random over some. Yeah, yeah, yeah. I mean, yes. Aishwarya, how do we handle outliers in EDA? Aishwarya, I just covered outlier handling very basic way, but I will have a separate session on that, because anomaly detection is it's basically my area, because I have worked on anomaly detection for almost 1.5 2 years. Okay, especially into that network analysis and all those things. I'll have a separate session on that, where I will take some time series data sets or some these kind of data sets, and we'll try to see how to do the outlier detection. Okay, so here I haven't done outlier detection here, so I haven't used that outlier thing here. Okay, so, and next one is information. Information basically gives you what are the total number of columns, how many non-null, how many null values, and all those things. Okay, let's move ahead. Here I'm trying to plot the data and see. I'm really sorry. Next, okay, we'll see. Next Sunday, I'm planning to have a Django class, machine learning model deployment using Django. But in case I'll try to see next to next Sunday, I can do that. Okay. Okay, let's move ahead. So we can see this particular piece of code I am using to identify what are the percentage of missing values. Okay, I'm trying to plot each and every column that I have, and you can see None of them has missing values. Is it possible? It's not possible. Why it is showing 0%? I will talk about that in the next few things. Okay, missing value. This is the initial intuition. Here we don't have any missing data. Okay, general thumb rules for features with less missing values, we can use regression to predict the missing values or fill the mean of the values. For features with high number of missing values, it is better to drop those columns as they give very less insights on the analysis. But again, there is a catch. For example, is car and car type. People having no cars will obviously have car type as null, right? But that doesn't make this column useless. So decisions has to be taken wisely. You always have to see the domain knowledge. You have to use a domain knowledge and then only you can do it. Okay. After your missing data, uh, yes, mean value will be robust to outliers. That's for sure. That's the reason I told that this is just one of the ways. This is not the best way. Okay. Then comes your data cleaning part. So we'll try to. So what we're doing is we're just copying a data because the original data set we don't want to misutilize it. So we are just taking a copy of that. Here I'm just converting the total charges because initially total charges was an object variable, right? But we know that this is an integer or a float variable. So here I'm converting into numericals. pd.to numeric total charges. Now after that, I'm just doing is null sum. Here you can see there are 11 is nulls. That means there are 11 null values. So what we are doing is we are trying to drop these 11 values. Okay. As we can see, there are 11 missing values in total charges column. Let's check these records. So these are the records. So here missing value treatment, since the percentage of these records compared to total dataset is very low, which is 0.15%, okay, it is safe to ignore them from further processing. Then comes your, okay, here I have done the missing values. Here I have done some techniques because I have used my domain knowledge to convert the tenure uh, to a new categorical variable. So I'm deriving some metrics out of it. Okay. So let me see if I have questions. I have any questions? Random over how do we handle outliers? I think I have covered. Please next Sunday. What is Xtix? Wiki Xtix is an I would say. So okay, let me. If I have to explain each and every method, it's going to take a lot of time. It's basically a part of matplot library. It's one of the annotation functions in the pyplot modules. Okay, and it basically gives you how do you explain it? Basically, uh, it sets the current tick locations and the labels of the x-axis. Okay, so probably you take this code and see if you will able to understand. That's not a problem. You just change the values and change the font size. You will able to understand what is xticks. Okay, there are a lot of methods under your matplotlib libraries or pyplot libraries. Okay. Yes, it is used to label the x-axis. It is an annotation function used to label the x-axis. What does it do? Please tell how many months we learn data science to get a job. Okay, Mohit, very off-topic question. I will answer that, Mohit. Probably you can get in touch with me on LinkedIn. I will try to answer that. Okay. When you press Shift Tab after writing a function, you can check parameters, what function is taking, and accordingly achieve a result. Yes. Okay. Okay. So here I have used my domain knowledge to convert tenure into tenure groups. Okay. So here I have created bins out of it 1 to 12, 13 to 12, 424, something like this, 25 to 36. Okay. And I have removed some columns that are not required for processing like customer ID and tenure. If I had customer name, I can also remove the customer name. Okay. Now comes your data exploration. So these steps are very basics. Then comes your data exploration. What is data exploration? Here I have written a simple command for I predictor in enumerate telecom data to drop. I'm dropping churn, total charges, and monthly charges because total charges and monthly charges are numerical variables. On top of the other categorical variables with respect to churn, I have used churn as the hue. Okay, I'm doing a count plot, 𝐶bond.count plot. So here, this is a univariate analysis. Okay, you can see the graphs are uh, plotted with respect to all the variables. Now, once this is plotted, because if you plot one by one, obviously it will be very hectic for you to understand, right? So that is the reason I have used a generic function to plot everything. So once we have plotted, then we can analyze it. So let's try to analyze the data right now. Okay, I will again use a paintbrush here. Let's just do like this. Okay, so you can see gender. So first, okay, I don't like this brush. Okay, so I have gender. In gender, you can see not churned almost 2500 not churned males. So let's do this way. Males and females. How many males not churned? 2500. How many females not churned? Probably 2600. I don't know, but yeah, probably 26. How many churned? Probably 900. And how many churned from females? Uh, I don't know. It's probably 900. So what is the ratio? The ratio will be male 900 divided by 3400 into 100. What is the percentage? 26, almost 26%. For females, 900 divided by 3500 into 100, almost 25%. So this is how the data is telling me. For gender, for males, 26% of the people have churned. For females, 25% of the people have churned. What is the original data distribution? If I go back to the original data distribution, go back. Okay, you can see here, where is the percentage? 73 and 26, 26.5. Okay, let's go back to the plot. So original data had 26.5% churn ratio. Now, I cannot say that more females or more males have churned because the ratio is almost similar. Okay, so gender is not giving me good insights. Okay, Aishwarya, probably you can watch out this video again, because if I have to explain, uh, other people will get distracted. Okay, I have explained everything in details. What is churn, what is telecom retention, and all those things using slides. I'll just give you a brief overview, brief, what has been covered so far, so that it looks tempting and you can go back and watch out the video. But I will not be able to explain it again, Aishwarya. Okay. So gender is not giving me much insights. What is the next step? We have to analyze senior citizen. So let's go to senior citizen. Senior citizen 0 and 1. Because we are doing a univariate analysis, right? 0 means not senior, not senior. 1 means senior. So how many not senior? Uh, how many not churned? Probably, I don't know, 4500 not churned. How many churned? Somewhere around 1300. Okay. How many are senior citizens and not churned? Probably 800. And how many have churned? Probably 600. Okay. Now, what is the ratio here? Again, we will calculate 1300 divided by 5800 into 100. 22.4%. 22.4%. Oh, sorry. 22.4%. Okay. And how many are senior citizens? 600 divided by 1400 into 100. 42.85%. Now, this is something really good. This is one of the insights which is really good. You can see from the data that senior citizens are more likely to churn. One insight we got from univariate analysis is that senior citizens are more likely to churn. Okay. How can I access the video? The video is all yours. It will be there on my channel throughout. Nothing to worry about. I will just share the code and the presentations immediately after the session is over. Could you also schedule some more webinars on EDA, because this is something for which we don't have many good resources out there, and you are explaining. Okay, thank you, Itoko. I will also schedule one EDA session not relevant to telecom. Okay, I will probably pick one another use case with respect to banking, or I think we will take some financial or insurance based use cases. Okay, we'll try to analyze that. We'll schedule a session very quickly. Okay, thank you for supporting. So you're getting it right. For gender, we are not able to get any insights. For senior citizen, yes, we got some insights that senior citizens are more likely to churn. Similarly, you have to analyze for rest of the columns. So this is where your univariate, then multivariate, then bivariate, a lot of things. That is the reason EDA is one of the most important steps in a data analyst or a data science career. Many people ignore EDA steps, but EDA is very important. And trust me, people who have industry level experience, like I have industry level experience, I can tell you that at least 60% of the companies, they don't believe in model building. Many companies are hiring statistical analysis, statistical researchers only for EDA and these kind of analysis, for research work. For EDA work, analysis is going to be the key. Many companies are there who still don't believe in model building. They can still get a good amount of revenue, good amount of impact just by EDA. Okay, so also we can use detail and sweetviz. Yeah, sweetviz, yes, it's, you can use sweetviz. It will give you a lot of insights, but I think it's fun because the more automated tools you work, and tomorrow let's say you talk to your manager, hey, I have a library called as sweetviz, just use it and we'll get all the insights, and your job will be at stake if you if you do that, right? So it's always good to use multiple libraries, but it's always beneficial to do the naive EDA research and try to analyze data. That's going to be a very fun activity. Okay, let's move ahead. Let's go to partner. Let's go back to the black color. Okay, partner. uh yes and no. How many yes churns? Not churns, let's say 2700. For people having partner, how many churns? 600. Now no partner, how many not churns? Probably 2400. And churns probably 1200. What is the ratio? 600 divided by 3300 into 100. 18%. So people with partner less likely to churn. People with no partner, 600 into 100, 33%. Wow, we got an insight here. People with no partner, they are more likely to churn. So one more insight, no partner likely to churn. So this is how you have to go ahead and do such analysis. So you take this as an assignment and you do that. Okay, the more insights you get, the more information and more knowledge you would be able to pass to your data scientist. So he can analyze, okay, these are the insights, then he will take some decisions for model building or something else. Okay, I will not go through each one of them, but this is how it works. Okay, there are certain amount of data which is from human eyes, it is not possible to do that, but once you visualize it, you will have more understanding. Okay, these are the insights which we can get and we can focus on these areas. Similarly, let's say this one, online backup. You can see people having no online backup are more likely to churn. People having no internet service are less likely to churn. Okay, so these are the insights which are possible for univariate analysis. So next step, what I'm doing is I'm converting the uh, churn variable, which is my y variable, to zeros and ones. Okay, initially I had yes and no. Now I have zeros and ones. Converting all the categorical variables into dummy variables. So I'm using the get dummies and converting into dummies variables. Okay, so this is where I have done the dummy encoding. But it Even if I'm using get dummies, I have just converted into one hot encodings. Okay. But if I have to ignore one of the variables, then we have to do there is a concept of dummy trap, right? I explained. So we'll have to drop last equals to true. You have to do that. Okay. Right now I haven't done it because if I do it, if it will be difficult for you to understand, right? And then what I have done is I have done some relationship between monthly charges and total charges. So monthly charges, there is, you can see the total charges are increasing as the monthly charges increases, which is a very basic insight, right? Because monthly charges, let's say monthly my charges are $60 each. So obviously if the monthly charges will increase, the total charges will also increase, right? So it's a very obvious insight. So I'll not consider that. Next step, what I have done is I have done some KD plots to see what is the impact of churn with respect to monthly charges. You can see this graph. Churn is high when monthly charges are high. You can see churn is the blue line. So when the monthly charges are increasing, this particular area, the churn is increasing. Okay, the churn density is increasing. Similarly, you can also do KD plots for several other numerical variables as well. Here I have just plotted the correlation function into a bar chart. So basically you can see month to month is having the highest correlation with respect to churn. That means 40% correlation. That means people who are churned, they are like people who are having monthly contracts are more likely to churn. Similarly, people who are having 2 yearly contracts are less likely to churn because they are very closer to minus 0.3. Right. So I'm just plotting the correlation matrix with respect to churn in a bar plot. Okay. So you can see what are the derived insights. High churn seen in case of month-to-month contracts, no online security, no tech support, first year of subscription and fiber optics. Low churn is seen in long-term contracts, subscriptions without internet service and the customers engaged for 5+ years. Okay. And this is where I have done the univariate, sorry, not univariate, this is the numerical heat map analysis I have done. I have simply called the correlation function. This is data frame dot correlation. I'm just passing it to the seaborn heat map library. Okay, here you can see, let me just zoom out a little bit, it will be easy. So green, this one, which is the brown box is zero point 0.8. Now you can see this brown box. So phone service no is, okay, wait, not this one. Phone service no. Let's see which column is this. Phone service no is highly correlated with multi-lines no phone service. Similarly, all these things you can analyze and see which are the numerical variables who are having high correlation, which are having low correlation and all those things. Okay. Then I have done the categorical bivariate analysis. So here what I have done is from the original data set, I have converted the data into two different data frames. One is my churned customers and one is my active customers. Okay, as I told you, my main aim is to analyze the churned customers, right? So new df1 target 1, new df1 target 0. So I have written a method here. I, again, if I explain this method, it will be a little bit tricky, but you can take this code. Tomorrow, if you have to do bivariate analysis, you can reuse this code. Simply, you just reuse this code. You just have to pass your data frame. You have to pass column 1 and you have to pass your hue. That's it. Okay. So here, let's say I'm passing partner with respect to gender. Now, let's analyze this one. What will be the insights? Let me have this here. So, partner, let's say male and female. I have two categories. Partner, sorry, let's redo this. Male, female, partner yes, partner no. So how many people? Males, partner yes, how much? 350, somewhere around that, 350. Partner no, partner no, males. Somewhere around 580. 580. Okay. Partner no males. Partner no males. Sorry, partner no females. I'm mistaken. 580. What is this? Partner yes. Partner yes. Females. Partner yes. Females. Partner yes. Females. Okay. 320. This is not 580. 320. Okay. And partner no males. Somewhere around 580. And this is somewhere around 620. So you can see this is the data which we have right now. So which are the categories? Partner no females. So as we remember in the partner, okay, we hadn't analyzed the partner, right? So let's analyze the where is senior citizen. Let's see where is senior citizen. Senior citizen, senior citizen. Okay, let's analyze this one because we haven't done the partner analysis in the univariate, so it will not be related. Like I will not be able to explain you. So let's say senior citizen. Senior citizen with respect to gender. Okay. The first insight which we got is senior citizens are more likely to churn. Right? That we remember. Right? Senior citizens are more likely to churn. 42% ratio. Now let's see senior citizen with gender. What do we see? Let's say I just draw male, female, senior citizen, non-senior citizen. Okay. Senior citizen male, 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 male. How many? 300. Let's say I don't know, probably 80, and this is probably 100. Sorry, 100, 100 or something like that. 100. Non-senior probably 680 and 700, something like that. Okay, so you can see senior citizens, more females are likely to churn. Okay, but again, it's very marginal difference. But as compared to males, female senior citizens are more likely to churn. This is what the data is telling us. This is how you have to analyze, and you have to analyze with everything like contract type with gender. Let's say this one, monthly to monthly contract, male and female almost similar. 1 yearly contract, you can see males are more likely to churn with when it comes to their female counterparts. Similarly, okay, this one, this is a very good insight. You can see payment method for churned customers. For electronic check, almost females and males are having equal ratio. Male check, again, almost equal ratio, but yeah, males are more churners. Bank transfers and credit cards. As compared to their male counterparts, female are more likely to churn. So females who have their payment method as bank transfer or credit card automatic, they are more likely to churn. I don't have the reason why it is happening, but this is how the data is telling us. Okay. So this is how you have to do the analysis. You have to analyze everything. So conclusion, this is not the final conclusion because a lot more can be done. There is always a room of improvement, right? So just 4 to 5 conclusions I have done. You can take this as an assignment and try to analyze further and see what all insights are possible. So people who are going out for interviews or people who are writing or mentioning this use case in their resumes, I'm pretty much sure that this this session has added values to it. You will have more insights, you will be having more understanding on the domain, more understanding on the use case. You will have a better explanation capability in terms of in the interviews. Okay, in case you have any question, guys, just uh, I will keep the call open for 5 more minutes. In case you have any questions, write down in the live chat. And yes, this is not the final conclusion. I will leave it up to you to uh, analyze the data further and give me insights. If you want, I can just populate the final conclusion as well, but it doesn't really add values. So you can just take this piece of code, analyze, take good amount of 2 3 days, and then come up with the final conclusion. Okay. Any questions? Anybody has any questions? Next class is going to be, I'm not pretty sure, I don't have any speakers, but I think next class probably is going to be either on Google Analytics or it's going to be on. I'll have to see, but yeah, if you are part of my communities, I will definitely explain you. Definitely let you know what will be the next topic. I just joined now. Where did we get the data set from? Suhaib, this data set is a public data set. So, but yeah, you can just go through this video to understand more about the domain knowledge part as well, because I have explained everything about the domain knowledge, what the data is all about, what is telecom retention, and all those things. Will the recording be available? Yes, the recordings, the YouTube video is going to be available for you all throughout. Nothing to worry about. EDA in feature engineering, selection subparts. EDA in feature engineering, feature selection sub. I couldn't get you, Gopi. Feature selection is a part of EDA. Feature engineering is also see, feature engineering, there are two different techniques. When it comes to model building part, feature engineering, there is a different set of feature engineering techniques which you understand, but there is some feature engineering techniques which you do in the EDA parts as well. Okay. Feature engineering, the term itself is very clear, right? You have to engineer, you have to understand the features. That's what feature engineering is all about. Engineering, what is engineering, right? So it's a very generic term. It is a part of EDA, it's a part of model building activities as well. Similarly, feature selection also plays a very vital role in EDA. It is also done in the model building part when it comes to the model building. Okay. Is it good to apply standardization and normalization for any type of model or only distance based? It's advisable to do it for everything. So not an issue. Please start machine learning algorithms. Okay, Meet, I will. I am planning some. I have something in my mind. I'm planning to do some 5 days workshop or something like that for machine learning enthusiasts, so that I can explain everything in details. I'm planning that. Probably it would be by June or something. I will inform that in the channel. But yeah, only if I have good amount of participation, then only I will be able to do it, because it takes a lot of efforts for these kind of sessions, right? So we'll see. Or else probably once I get 10,000 subscribers, immediately I'll go for that. Sir, for model making, feature engineering, and hyperparameter tuning are two different things, right? Yes. Feature engineering is basically understanding the features, which features are important, which are not. Hyperparameter tuning is with respect to the model. Let's say you create multiple models and you finalize that model 1, 3 are the best performing models so far. Then you probably take the next step and try to do hyperparameter tuning in those models. You try to change the parameters, you try to change them, try to run the models on different parameters, and then see which model is giving you best results. Thank you, Sagar. Thank you. Awesome session. Thank you, thank you, thank you. Any other questions? Any other generic doubts? I'm also planning to go for one-to-one. Sorry, these kind of live sessions for doubt clearings as well, with respect to your career and all those things. I'm planning to do. I'm planning a lot of things, guys. So a lot of important news will come soon. Meet, I don't have any answers in this session, because publicly I cannot talk about any forum. So I will not. I'll keep it open, Meet. But I don't know. See, the basic thing is that I will just give you a direction, Meet. Before enrolling any course, try to see who the trainer is. Try to see if the trainer is having hands-on industry level experience or not, because a lot of courses are being, because currently edutech is business. Okay, people have made this business, including me. I also have a startup where I teach people end to end. uh, so I'm not promoting my course or something like that. I always recommend people to learn as much as possible from free sources. But in case you are not able to do that, you can go for paid courses. But when it comes to courses like you mentioned, Meet, you have to take some precautions. You have to check what is the total strength, how many students are being taught in each batch, who is the trainer, uh, okay, one of the trainers is whom you mentioned, but he's not your primary trainer. But yeah, you can do an R&D whether other trainers who are being who are teaching are good or not, if they have industry experience or not. These are the things which you need to see. Okay, analyze. I will not tell any pros and cons in this live session. In case you want to have, if you want to connect with me, I can tell you. Okay. Unfortunately, I joined very late. Okay, Mohammed Soeb, not an issue. You can go through this session later on. Not an issue. Uh, Sir, I'm going to Canada soon. So, is it good for data science in Canada? Well, Meet, that depends. In Canada, currently, the session has completely moved on from EDA to a general discussion, which is okay. It depends upon situation because currently there are a lot of job scarcity in Canada. Okay, if you're not aware of, I'm just letting you know. Lot of job scarcity in Canada. I have many students who are looking out for jobs in Canada right now, and if you're looking out for PR, Canada PR, if you're looking out for masters in Canada, then you can go for it. Masters is a possible option. You can go for it and then you can find a job there. But if you're looking out for job from here in India through PR programs and all those things, I don't think it is possible. Many companies, many institutes will probably tell you that you have a very wonderful profile and you will be able to get a job quickly, but that's not the case. You will just end up wasting money. It will not happen. Okay, that's fine. That's fine. If you are doing masters in data science from Canada University, that's fine. You can go Canada and you can find a job. Not an issue. Not an issue. Okay. Anybody has any questions, or else we'll wind up the session, guys. It was nice. I think it was nice session. I never expected it to go beyond 2 hours, but I think it was nice. It was an end-to-end session. People learned a lot of things. Data encoding techniques. I will try to publish a video tomorrow. Tomorrow evening, you will get everything related to data encoding techniques. Okay, that's it, guys. Thank you, everyone. Thanks for joining me. Please like, share, and subscribe subscribe the channel, and please share this video among as much people as possible because YouTube recommends videos based on likes and comments. And feel free to interact in the comment section as well. This video will be uh, quickly live. It will be available on YouTube very soon because it's a live session, right? You will not be able to see the video immediately. You will not be able to comment it, but later on you can comment. Okay, that's it for today's video, guys. Thank you, everyone. Thanks for joining in. Next class will be on some topic. I will inform you, and that's it. Thank you, everyone. Goodbye.